Hi everyone, my name is Jeff. I'll be going over Git for this year's HOTH 12. Here's the QR code for the slides to this workshop, and here is a README of uh, the workshop to Intro to Git. What is the agenda for today? So I'll be going over what is Git, what is GitHub, installing and configuring Git, what are repositories, branches, and some other terms that you should probably know. What is a Git workflow, creating a repo. I'll be demoing all of this. And at the end, I'll go over some tips and best practices. So, what is Git? Git is a version control system. It is used to track changes in your source code, and it saves points in your code like a snapshot or like taking a checkpoint. It also keeps history of your code. So let's say you make some changes and you call that a new version, like version 2. You can always go back to version 1 in case you mess up and break your code in version 2. Git works similarly to a Google Docs. So now imagine you're assigned a group report from your class and it has to be turned in by the end of the week. You split up the work among your group members and create a shared Google Doc to work on. Each person works remotely on a section of the report, and later you combine them to make a cohesive report. So let's say someone messes up the data and you guys need to revert to a previous version. You shouldn't worry. Every time a change is made, Google Docs keeps track of who and when those changes were made. So all you need to do is go back into history and click revert to a previous working version so that your Google Docs is not messed up. So once you're finished with all your parts, all you need to do is combine your sections and you're basically done. Just like how Google Docs tracks changes and allows multiple people to edit a document simultaneously, Git tracks code and allows developers to periodically upload code and collaborate with each other. So you may think that Git and GitHub are the same thing. You've probably heard of both these terms, and you're probably confused on what the difference is between these two things. So what is GitHub then? GitHub is an online platform that builds around Git and makes it more user-friendly. Without GitHub, Git would have to be accessed from the command line, requiring more technical knowledge. It is also much easier to use GitHub than just to use Git straight from your computer. GitHub allows for cloud-based repository services, meaning you can store your code on the cloud instead of just your local device. So what does this mean? It means that let's say I lose my computer, I'll still have access to the repository on the cloud because it is stored on a server somewhere else and not on my personal laptop. GitHub enables multiple developers to work on a project at the same time without interfering with each other's work, and we'll get into how that works later. So let's get into installing and configuring Git. So Git can be installed on like multiple systems. Here's how to install Git for Macs. You would first need to open up your terminal and then install Homebrew. What Homebrew does, it basically makes installing Git much easier for your computer. Once you have Homebrew installed, by clicking this link, you can go on the slides and then click this link, install Homebrew. And once you have that installed, do brew install git. So to check that you actually have git installed, do git dash dash version to see if you have the correct version installed. So installing Git for Windows and Linux. For Windows, you would follow this link and just do whatever it says to install Git. Or you can just search up Git for Windows in your search bar and you'll get to the right link and then install it from there. To check that you have Git installed using on your Windows, just do git dash dash version as well. For Linux, you would do sudo apt-get install git all. And for other systems, click this link and follow the directions. So to configure Git, basically you just want to set your name and email address. So whenever you make changes, it'll have the right name and email address. You would do git config global user.name Bob if your name is Bob or whatever you want to set your name to. Or you and to set the email, you would do git config global user dash dot email bob at gmail.com and replace your email with whatever or replace your email with bob@gmail.com. To check that you configured it correctly, do git config dash dash list. What this will do is basically just show your name and your email address. So now let's get into a demo. I'm going to be installing Git. So I'm on a Mac, so this will be on my terminal. Um, I have Homebrew installed, so I won't do this for now. So you just install Homebrew from here, and I have that installed. And then you would go back to your terminal and do brew install Git. I already have Git installed as well, so I won't be clicking enter here, but just imagine I did. Um, and since I have Git installed, I do git dash dash version, and here you can check that I have Git installed. Great. All right. So to configure Git, you would do git config dash dash global dot name, whatever your name is. So mine will be Jeff. I already have my name set, so I won't do that for now. Um, and then you would do git config dash global, email, and then my email would be like jeff@gmail.com. I also have mine configured, so I won't be doing that as well. And then git config dash dash list to list out your email. I don't want to show my email, so I won't be pressing this as well, but just imagine I did. If you did everything right, it should show your e name and email. All right, great. Um, so now let's get into some terminologies that you'll need. The main thing that you probably should know is repositories. That's where all the files, um, that's where all your project files, your history of changes, including previous versions of your code, are stored. It can also be called repos. Repos is just a shorter version of repositories. And there are two types of repositories, local and remote. A local repository is stored on your local machine. What this means is it's basically like what you're working on, like your personal computer. It's not the cloud that we're going to get into later. Um, and it holds the information such as files and folders that Git tracks. So you can put Git into that folder and it'll track the changes in your code. You can also make commits and branches on this repo. Commits and branches are some terms that we'll get into very shortly. All right. So what is a remote repository? A remote repository stores your repository on an online server like GitHub. Basically, it stores it on the cloud instead of your local device. So in case you lose your laptop or whatever device you're working on, you still have a copy somewhere else. It basically is a backup of your code. You can also create a full copy of your remote repository. Uh, so if you ever wanted to work on a repository you found online, you can do that. So let's get into a little demo of how a repository works. So let's start off with three files. These are the original files, and we can call this version one. You can see that it's stored in the repository. And now let's say I want to add a new feature and I have to add two more files. I'll call this file 4 and file 5. Um, and then I commit this to the repository. So basically, I just move it. I make a new version called version 2, and it's also stored in the repository. And as you can see on the right, version 1 and version 2 are both stored on the repository. So in case version 2 actually doesn't work, I can always revert back to version 1. So what is a branch? Basically, a branch is an independent line of development where you'll be able to work on new features without affecting the main branch. So it works like a trunk. It's basically the main line of code, and it's now called the main branch. It used to be called the master branch. So as you can see in this diagram, it says master, but this is the exact same thing as branch. So in older versions, it was called master, but because of political reasons, it was changed to main branch. So now let's say I wanted to add a new feature to this main branch. I'll be referring to main branch and master branch as main branch. So master and main are the exact same thing. So here, the main branch is in blue, and I wanted to add a new feature. I will branch off the main branch so I don't affect the main branch. And then I have a new branch called new feature, and I change the files here. And once I finish with those changes, I merge it back onto the main branch. The reason of the reason I do this is because I don't want to affect how the main branch currently looks because that's the branch that is currently deployed, and I don't want to affect that. So basically, I branch off and then do whatever I want to on the bottom, and then merge it back on. So, what is a merge? It's basically the process of combining two separate branches into a single branch. This is necessary when there are two developers working on the same project. So, basically, if you want to make changes to different parts of the code, you can do that. And then here, it's basically the same thing. You have the main branch. You want to make a new feature, and then you merge it over here back onto the main branch. So now the main has a new feature in it. So when you merge, sometimes it can cause merge conflicts. Basically, what that is if you have two developers working on the same line of code, and then they want to merge it back onto the main branch, sometimes the Git won't know which one to actually use because they changed the same line of code. So it'll cause a merge conflict, and it'll tell you to manually resolve it. So you have to edit it instead of Git doing it for you. So here it'll look like this when you have a merge conflict. Basically, you can edit it right here and then do whatever change you want so that you can actually merge it. So uh, you can resolve the conflict. What is a commit? Basically, it's a snapshot of your current work. Each commit usually has a message and timestamp next to it, so you can reference it later. And it helps you track your progress, and you can roll back to previous commits if needed. So if you make a mistake and you want to roll back to a different commit, you can do that with Git. So once you commit your code, so you made some changes to your code and you committed it, now you want to push it so that the local commits, which are the changes you made on your computer, you want to push it to the remote repository. So you push it onto the remote repository, which is on the cloud. It doesn't automatically push to the cloud. And you want to make your changes um, like visible to your team on the remote repository. It allows people in your project to incorporate it into their own project. So once you push it, you'll have a pull request. This is a request to merge your branch into another branch, most likely the main. And it allows people on your team to review your code, comment on your code, and make modifications to your code in case they don't like how it looks and they need to make like some changes. Um, so it'll look like this once you push it. It'll say compare and pull request. So you want to click that button and it'll give you a short description. Well, it will ask you to write a short description for what changes you made so that your team can properly review your code. So pull is different from a pull request. Pulling means that you retrieve code from the main and merges the latest commits from the main branch onto your current branch so that it helps resolve merge conflicts before they occur. It keeps your code up to date with recent commits, and the best practice is to pull before pushing so that it can help resolve merge conflicts before they occur. So, what is a Git workflow? A Git workflow is basically a set of practices that a team of developers can use to manage change and collaborate on a project. It's basically the outline of steps that a developer can use to develop a project. Git operates with three main states, the working directory, the staging area, and the repository. And a Git workflow provides a roadmap on how to move through those states. So here's a diagram of the three main states. Here we have the working directory. It's where your local files and where you edit the code is. And next you want to stage the file. So it's basically the middle between the working directory and the Git uh directory. It's basically where you made some changes and then you want to commit it later. So you put it into the staging area so that those changes can be committed later. So basically you indicate what changes you made and then finally you commit it. And here are where the Git directory is. So that's where you're committing to. So the Git directory is where you create, edit, and manage files on your local machine. And basically it's your project folder on your laptop. For Git, you need to instruct Git to track changes in this directory, and I'll show you how to do that later. This means that Git monitors modifications, additions, and deletions of files, allowing you to manage version control efficiently. Next is the staging area. This is where you indicate what changes you want to be included in the next commit. Once you finish a change, you can put it into the staging area to get ready to push it onto the remote repo. Basically, it's the middle area between the working directory and the repository. Next is the Git repository. So this is the same as I have mentioned before. It's where the project files are stored, holds snapshots of the code, and contains everything needed uh to track changes. I think that's a typo. Here we have the working area, the staging area, and the Git repository. So you move from the working area, which is your local device, onto the staging area, and then you commit and push it onto the Git repository. Here are the commands for the three main states. Git init, which basically allows Git to track your working directory. Git add, and don't forget the period. This adds all of your changed files onto the staging area to get ready to commit. And then here you do git commit dash m, and then a short message describing what changes you made to push it onto the repository and commit it onto the repository. So you can also clone Git. Cloning allows you to copy a remote repository, such as one that you found on GitHub, onto your local machine. Once cloned, you'll have full access to the files and can modify the code locally. It is especially beneficial for collaborative projects, enabling team members to work together. And it makes sure that everyone receives an identical version of the repository, ensuring consistency across the team. And this ensures that everyone is working from the same code base and it avoids discrepancies. So now it's finally time to start using GitHub. Firstly, what you want to do is to check that Git is installed using git dash dash version. And now you want to go on GitHub, create an account, and then now you want to create a repository. You can click this link to create a new repository, or you can just go on your GitHub and then there'll be a button called create, or I think it's called create. And then you can either decide whether to make it public or private and create a name for that repository. Public means that anyone can access that repository. Private means that only people with permission can access it. And you can find this repository under your profile page, under repositories. Now create a folder on your device and open it with a text editor like VS Code or Xcode. Make sure you're in the file path of the folder. So CD into this folder path and do this command in the terminal to initialize Git inside that folder. So Git init. Now you want to create a commit in your local repository. You would do git add dot. What this does, it adds your files to the staging area and then you would commit it using this command here. So now that you committed your first file, what you want to do is sync this local repository with the remote repository. What you want to do is do git remote add origin and then the GitHub repository link. You would copy it from somewhere like this. So here I made a Git repository named hello, and then you would copy this link and instead of these brackets here, you would just put this link over here. So now your remote repository and local repository are linked. Now you want to rename the branch that you're on to the main. So you would do git branch dash m main. Now you push it, git push dash u origin main, which pushes the your commit to the remote repository so you can see those files. And in case you ever wanted to clone a repository, you would do git clone and then the repository link. So now I'll do a demo. So let's go on to here. And let's say I wanted to name this hack fan. Okay, so I'm a fan of hack and I'll make this private and then I'll do create repository. So here you can see this link over here. You would want to copy that. So copy, and then what you want to do is um I already made a folder, and here you would add a file. So I can name this like hackcool dot py. So I'm making a Python file, and let's say I print hack is cool, right? So now I would want to open up the terminal inside this text editor. And firstly, I would do git init. So now git is initialized inside this file or this folder. Okay. And then I would want to add my file to the staging area. So I would do git add dot. Now it's added to the staging area. And now I would commit this. So git commit, um, make a message, be like first commit here. So now I committed it, and now I want to add it to the origin or connect my remote repository with my local repository. So um git remote add origin and copy this link here. So now my local repository should be connected to my remote repository. And then now I would want to name this git branch name it main. So this branch is now named main. And then I would want to push it. So push origin. Okay. So now it should be pushed onto the remote repository. So now if I restart this here, first commit, and here we have print hack is cool. Cool. Nice. Okay. So that's what we did. And let's go over branches one more time. So an overview of branches. Firstly, you'll be on the main branch. And if you ever wanted to make a new feature, what you would do is make a new branch so you don't mess up the main branch. And at the end, once you're done with that feature, merge it back onto the main. So here's how to make new branches. After creating your main branch, you can make a new branch to work on some different features. You would create a new branch and switch it to git checkout dash b branch name. What this does, it basically creates a new branch and it automatically switches to that current branch. So now you would work on whatever changes you want to make, and then you would do stage, commit, push your changes. So git add, git commit, and then git push. The only difference here is that you would write the new name or the branch name that you currently named it instead of main, so that you push that branch. So here's some other branch commands. You can do git check out some branch name if there are multiple branches and you want to switch branches. And here you would just switch out the branch names if you want to push different things. Okay, so merging branches here. After pushing, you will need to submit a pull request. To do this, go to your GitHub repository to see your current push and click on the green button called compare and pull request. GitHub will tell you if there are any merge conflicts, and if there are, it'll say resolve conflicts. You can directly edit on GitHub to resolve those conflicts. Once there are no more conflicts, you would merge that branch onto the main, and you have successfully added a new feature. So to summarize, this is what you would do. Make sure you're on the main branch. You would do git checkout main and then pull so that you pull from the remote repository to get all the current commits to that main. And then If you wanted to add a new feature, do git checkout dash b, the branch name, and then make your changes and then stage those. So git add dot, and then commit those, git commit, and in your message, git push to push those, to push your commit. And then you'll have a pull request, and then you will need to resolve any merge conflicts. And then finally, once you resolve those merge conflicts, you would merge the pull request, and then the the main should reflect your changes. So our last demo of the day, let's do print hack is great and print hack is awesome. Okay, so um, let's say I have those changes, and then I'm on the my current branch is the main. So I would do git checkout main. Okay, and currently I'm up to date. So, but I'll just do git pull just in case. So I have these changes already. It shouldn't do anything because the main is just this, and I already have this here. So I changed it a little bit. Um, and then I pulled, but that doesn't do anything because I already have this. Okay. And then I would want to make a new branch, git checkout branch, and adding new print statements is my message. Or this is my branch. So I'll just do adding branches or adding prints. Okay, so I am on a new branch called adding prints. And then what I would do now is now I would add more changes like print hack. Okay, so I haven't committed or staged any of these three changes yet. So now I'll need to stage that. So git add dot. So now it's staged, and you can see that there's no more green line here, and it's in the staging area right now. And then I would do git commit it's a message adding three prints. Is my message. Okay, so now it's committed. So you can see that it changed. So all of these are committed, and now I would need to push it. So git push origin, and then the branch name adding. Okay, great. So now it's pushed, and if I try to go back to my repository, I I see compare and pull request. I would add a short description. Okay, create pull request. So now there's a pull request, and you'll be able to find it on this pull request tabs, any pull request. So click this, and then there are no merge conflicts. So I can just press merge pull request. And then here, everything looks good. I would confirm merge, and then great. It says successfully merged. And if I go back to this code, it'll have the reflected code over here. So everything works, and we should be good. So that would be the end of this demo. And to review some commands, so git status would show the changes made since the last commit. Git init would create git in that current folder. Git checkout dash B would create a new branch and switch to it. Git checkout, just the name, would switch to an existing branch. Git add dot would stage all your changes into the staging area. Git commit would commit those changes. Git push would push those changes to the remote repository. And git pull would integrate those changes from the remote repository to the local branch. All right. Thanks for watching. You can ask any hack officers if you have any questions. And hopefully you enjoyed this presentation. Thanks so much. Bye.